So we're going to turn our attention to solving linear equations. So let's look at some examples, practicing solving linear equations. So when we say to solve a linear equation or solve an equation, we're trying to solve for the variable. Get the unknown by itself on one side of the equation. So here we start with x plus 14 is equal to negative 12. So if I want to get this x alone on the left side, I need the 14 to not be there. So we can always balance equations out by doing the same thing to both sides of an equation. So if I add a number to the left side, I have to add that number to the right side. So if I want to get rid of the 14, since it's plus 14, what we'll do is we'll subtract 14. And if I subtract 14 from one side, I need to subtract it from the other. So on the left, I would get x plus 0 and on the right, we get negative 12 minus 14 is negative 26. And then x plus 0 was just x, so we get x equals negative 26. Now the thing about an equation, the way you solve for a variable, is you can always check your work. And a lot of the time it's worth it to take that extra step to make sure your answer makes sense. So what we do is we plug x in, our answer in. So x equals negative 26. So we'll put negative 26 in for x. And negative 26 plus 14, it does equal negative 12. So we do have a legitimate solution to this problem. We also sometimes encounter problems that have multiplication involved. So if we have, say, 3x equals 111, this means 3 times x equals 111. So how do I get rid of the 3? So to undo multiplication, 3 times x, we divide by that 3. So if we take and divide by 3, we have to do the same thing to the other side. So 3x divided by 3 is just x, and that will equal 111 divided by 3, which is 37. And again, it's fairly easy to check our answer here with a calculator maybe. So if we do 3 times 37 and type that into our calculator, we do indeed get 111. Okay. So now let's look at an example or two where we have to combine both these things, where we are either adding or subtracting something from both sides of the equation and then doing a division to get the variable by itself. So let's look at the problem. 4x is minus 17 is equal to 27. Now, when you're doing a problem like this, you want to get the term with the x by itself first. So we want to get the 4x by itself. So the first thing we need to do is to somehow get rid of this minus 17. Well, so if I've got minus 17, to get rid of it, I would add 17. So we'll take and we will add 17 to both sides of this equation. So showing a little too much detail, negative 17 plus 17 is 0, equals 44. So now we have 4x equals 44. To get x by itself now, we divide by this coefficient, divide by this 4, and we get x equals 11. Again, we can go back and check this. So let's go back and plug this into our equation. So 4 times 11 minus 17. If we follow our order of operations, we would do this multiplication first. We would do 4 times 11, so we get 44 minus 17. And 44 minus 17 is indeed 27. So this works out. Because when we plug x in, what I get on the left is equal to what I get on the right. Let's look at one more example on this video and look at 2x plus 3 is equal to 5x plus 2 times x plus 1. Okay. Maybe you want to hit pause here and try to solve this equation on your own, and then check your work against mine. Maybe not. All right, so we would start by simplifying both sides of the algebraic expression. We haven't had to do that in the first few here, where we just started off with expressions that were simplified. There were no like terms that we could combine. But over on this side, we might have some like terms here, because I have this 2 outside of the parentheses here. So I want to start by distributing that. So in this next line, we have 5x plus 2x plus 2. We have 2x plus 3. Now, what can we combine on the right here? Well, I've got 2 like terms here, 5x and 2x. So 5x plus 2x is 7x. So we get 7x plus 2 on the right, and we get 2x plus 3 on the left still. So how do I get x by itself? Well, we've got x's on both sides, so we need to pick a side. So I need to somehow move this 2x over to the other side, or get rid of it. So what we can do is we can subtract 2x from both sides. So 2x minus 2x is 0x, so that's just 0, plus 3, equals 7x minus 2x now is 5x, plus 2 still. So now we're kind of set up to win here, because it's sort of like all the other ones we looked at. So I need to get the 2 off of that side, so we can subtract 2. We get 1 equals 5 over x, or 1 equals 5 times x. So to finish, we would divide both sides by 5. And we get x equals 1/5. Or if you prefer decimals and are working with decimals, you would have 0.2 would be our solution. And again, we can check this. It's going to be a little bit more work, but we can certainly check it. So let's check the left side and the right side separately and see what we get. So if we want to use the decimals here, if we have 2 times 0.2 plus 3 on the left side, 2 times 0.2 is 0.4, so we have 0.4 plus 3, and we get 3.4. Okay. Now we could do the same on the right side, plug x equals 0.2 in, so we have 5 times 0.2 plus 2 times 0.2 plus 1. So following our order of operations, we would start by doing 0.2 plus 1. We get 1.2. Now we've got 2 multiplications to do. We can do them at the same time. So 5 times 0.2 is 1. 2 times 1.2 is 2.4. And 1 plus 2.4 is 3.4. So this works out great. When we plug our x in, the left side is equal to the right side, so our solution checks out.